Fourth up today, we're looking at units. There are 7 quantities that are not related to each other at all, and these are the 7. The units of these 7 quantities are called base units by OCR and Edexcel, and they're called fundamental units by AQA. All other units are mixtures of these. So for example, pressure measured in pascals, we're going to express the pascal in terms of base units. So this is how you do it. You write a formula for pressure. It doesn't matter which one. Obviously some will get you to the answer quicker than others, but it doesn't matter which one. So there's a formula for pressure. And now what you do is you go, right, force, what's that measured in? Newtons. Is newtons on that list? No. So I'm going to need another formula for force. So I'm going to go, again, any formula you like, but this one gets me there nice and quickly. So F equals ma. So I've put a formula in for force. And then area, what's that measured in? Meters squared. Oh, that's okay, because meters is in the list. Okay, so I don't need to change area. Okay, now I'll do it again. Mass measured in kilograms. Yes, that's on the list. Acceleration measured in meters per second squared. That's also fine. And area, we said, was already fine, meters squared. So now everything in that formula there is measured in mixtures of these 7 base quantities, base units. So now we're going to substitute units. So the units of P are going to be equal to the units of mass times the units of acceleration divided by the units of area. And now treating these just as though they were variables, we tidy up, simplify and tidy up. So this m cancels with one of those m's, and I find that 1 pascal is equal to 1 kilogram per metre per second squared. So that's how you do it. So that's the combination of the base units that make the pascal. Now, a related question type to this is where the question asks you to show or to prove that a formula is homogeneous. Homogeneous means that the units on the left-hand side are the same as the units on the right-hand side. And if you think about it, that has to be because there's an equal sign in the middle. So if that's 2 newtons, then whatever's on the right has to be 2 newtons as well. That's not immediately obvious here, but if you express both sides in base units, you should then be able to see that they are in fact the same. Okay, so this is a common one, they like this one. So we've already done pressure using this formula. So you can't use, obviously you can't use the same, you can't use rho GH on both sides. So on this side for pressure, we could use that formula and get this. So you would write left hand side, and then you would write everything we had up there. So I'm just going to go ... kilograms per metre per second squared. So that's our left hand side. And then you would write right hand side. Okay, so on the right hand side, we've got rho GH. Now then, let's do our check. So rho is density. It's measured in kilograms per metre cubed. So that's totally fine. G is the acceleration due to gravity. So that's measured in metres per second squared, also fine. And lastly, height, which is measured in metres. So actually the right hand side is really nice and easy. We can put the units in straight away. Density was kilograms per metre cubed, gravity meters per second squared, and height meters. And then again, we're going to tidy up. So there's my kilograms. I've got m to the minus 3 times m to the 1 times another m to the 1. So that's m to the minus 1, and then s to the minus 2. And there you go. We've now shown it. So both sides have the same units.